Welcome to the University of New England's Planetary Health Council's fourth in a series of 6 events brought to you in collaboration with UNE's Center for Excellence in Collaborative Education. The Planetary Health Council's mission is to coordinate and elevate planetary health education and research initiatives, develop learning opportunities grounded in planetary health, and accessible to all members of its community, and educate and celebrate planetary health leaders who impact our workplaces and communities. I'm Alethea Caridi, UNE's Assistant Director of Sustainability and co-chair of the Planetary Health Council, and I'm grateful for your attention and participation today as we present this interactive panel discussion about what we can learn from the pandemic in relation to climate change. The pandemic has revealed vulnerabilities and inequities, much the same way that climate change does. What can we learn from these crises that can strengthen our community's resilience and adaptation? Just a few housekeeping items before our panelists introduce themselves. I'd like to remind us all to keep our microphones muted during the presentation so that our speakers don't have to compete with background noises. Also, the chat feature, which will be open throughout the presentation, and we encourage you to post questions or comments after our speaker presentations. We're going to read some of these questions to our panelists and let them respond to them. Please continue to include your program or your profession in the chat when you post comments, so that we can learn more about each other interprofessionally. On behalf of the Planetary Health Council and the Events Working Group and CC, we are really excited to have you all together today. And at this time, I'd like to introduce our panel moderator, Susan Faraday, Associate Professor of Marine Affairs in the School of Marine and Environmental Programs at UNE.
Terrific, thanks Alethea. Welcome everyone. It's terrific to have you join us for some thoughts about how we can learn from one crisis and consider another. I'm a faculty member at UNE's School of Marine and Environmental Programs. I'm also on the Planetary Health Events Committee with Alethea. I research how law and policy are applied to how we make decisions about the marine ecosystem, marine resources, and the human communities that interact with the ocean. Some of my research is on addressing microplastics in the ocean, how fisheries management may need to change in light of climate change, and how our national marine sanctuaries are managed. I teach our interdisciplinary marine affairs curriculum here at UNE, and I advise amazing students in the marine affairs major. I'd like to introduce one of them now, who is helping us with today's event. Caitlin?
Caitlin Irish. I am a senior marine affairs student at UNE. I also have a minor in English and writing as well. I'm involved with undergraduate student government as a natural science representative, as well as being a member of the women's lacrosse team. My role today will be helping get any of your questions and comments that you placed in the Zoom chat heard after each of our panelists speak. So make sure you keep those questions coming. And as Alethea said, if you haven't done so already, make sure that you are putting in the chat your program or area of study, as well as your hometown. Thank you.
Thanks so much, Caitlin, and thanks for helping us out today. Next, I'd like to introduce my colleague, Dr. Charles Tilburg. Charles?
Thanks, Susan. Yeah, so I'm Charles Tilburg, and I'm the academic director of the School of Marine and Environmental Programs and the director of the Arthur P. Gerard Marine Science Center. And I'm a physical oceanographer, and one of the things that I'm working on right now is studying climate change in the Gulf of Maine. So I'm going to be talking a lot about the physical ways that both climate change and the COVID-19 are being addressed and how they're being studied. And I'm going to turn it over to my colleague, Dr. Barry Costa-Pierce.
Good afternoon, delighted to join you. I am a professor of ocean food systems in the School of Marine and Environmental Programs at the University of New England. My research is on the nexus of food, particularly aquatic and ocean foods, water and energy, and people, both locally and globally.
Great, thanks everybody. And in advance, I want to thank all of our panelists for participating today. Now I'd like to introduce a documentary on climate change in the Gulf of Maine, produced by our own University of New England's Office of Communications. We'll be watching a 3-minute trailer to set the stage for our presentations. The full 23-minute documentary is available on YouTube. You can search for it with the title of the film on YouTube, and we've also posted the link in the chat on Zoom and on Facebook. Reckoning with Climate Change in the Gulf of Maine features Maine experts grappling with the impacts of climate change and their role in advocating for action. The Gulf of Maine is warming faster than 99% of the world's oceans, presenting a unique setting to study how a marine ecosystem and coastal communities are impacted by climate change. Now let's watch Reckoning with Climate Change in the Gulf of Maine.
The ocean doesn't care if you believe in climate change. The ocean is going to get warmer no matter what you believe. If we don't get this right, then our way of life is gone.
I have some hope. However, I will say that I am not going to paint a rosy picture. I think it's going to be challenging.
My biggest fear is really that this issue might be even bigger than we realize at this point.
Climate change is the single biggest threat to the survival of this planet. And in Maine, scientists are witnessing and studying the impacts of a body of water that is warming rapidly, right in their own backyard.
It's basically ground zero for climate change, with the Gulf of Maine warming faster than 99% of the ocean. It's happening right here.
The Gulf of Maine is important for two main reasons. One, it supports an incredibly large fishery in terms of lobsters. It's really, really important to the state of Maine. But what's more important, at least to me as a scientist, is it is warming faster than 99% of all of the oceans in the world. Like, this is a test bed for what's going to happen over the next 40 to 50 years all throughout the world's oceans.
My name's Dan Chadbourne. I've lived on the Saco River my whole life. My father was a fisherman before me, so I'm second generation fisherman. You can see the catch is less. When I was a kid, everything we fished was right in the bay. You could see everybody from here. And now the lobsters are outside because the water's colder. Little guys. Another nice one.
And ultimately, I think we will need some changes in the law because it's not built to regulate a really dynamic, changing ecosystem. It's just not.
We suspected it in 2012. 2012 was one of the warmest years ever for the Gulf of Maine, and that's where scientists started looking at how fast the Gulf of Maine was warming. Until then, we knew it was going fast, but we had no idea that it was warming as much as it was.
Well, lots of migration due to climate change is already happening in the Gulf of Maine. The perfect example is cod, which is basically gone out of the Gulf of Maine, where up in Iceland they're catching a ton of cod right now. All the cod which was here before.
And maybe it's going to take, as our species has learned in the past, a few disasters for us to sort of wake up. I hope not. I hope that we don't respond to disasters by building more walls, that we build more bridges.
We've set the stage now with some information about what we're facing in the Gulf of Maine. And now I'm going to turn to Dr. Charles Tilburg to share his thoughts about what we can take from confronting COVID-19 and apply to this important issue of climate change. Dr. Tilburg?
Thanks, Susan. So I'm going to set the stage, and I'm going to just talk about the similarities between both COVID-19 and climate change in terms of the basic science and how scientists have been looking at these two and just get very, very basic about how we're addressing these. So can we go to the next slide? So science is sometimes seen as a rather straightforward process. You know, the vaunted scientific method is frequently described as this inevitable march towards conclusions. And, you know, we're starting with observations. Then we pose a question and identify a problem. And then finally, then we do research. We search for existing answers or solutions. We then form a hypothesis. We create an experiment. Then we test that hypothesis. It's supported or it's rejected. It's not proven, it's supported or rejected. And if it's rejected, then we go back. And it seems like this nice orderly process. Once we finally supported our hypothesis, we can then draw conclusions and we can report out. And so here's an example of, you know, the well-known experiment supposedly that Galileo did, where he was looking at determining that objects fall to the earth at the same rate. And supposedly he observed that it seems like objects were falling at the same rate. And he formed a question, he formed a hypothesis. He then tested that hypothesis by going to the top of the Leaning Tower of Pisa. He dropped two balls that were the same size. They fell and they hit the ground at the same time. So he drew the conclusion that this is true. He then reported this out. This all sounds wonderful, and it is completely false. He did not do anything like this, because science doesn't really work like that. And one of the things about COVID-19 and climate change is that we're watching it progress in real time. In real time, science observations are incomplete. The questions that we ask may not be the right ones. Research is incomplete, and the process goes through many, many, many hypotheses and guesses until one is supported. So an understanding of climate change has been happening in real time during our lifetimes. Consequently, the public has observed the process in all of its messy, complex glory. Most science has not evolved in such a public venue as climate science has, and we see it as, you know, this stepwise process, which it really isn't. Now, the COVID-19 pandemic has evolved at an even faster rate than climate change science, can provide us with some lessons on understanding and then dealing with climate change. So both phenomena, the COVID-19 pandemic and climate change, are evolving in real time. Scientists are struggling, and I would add succeeding, in understanding the mechanisms responsible in real time. And then the public is addressing, or in sometimes not addressing the problem in real time or significantly later due to economic concerns. So for both of these, we've experienced mild effects early on. We listened to science as they hashed out the details, argued with each other, and then we made decisions that would have lasting effects before we'd experienced the full-blown consequences of each phenomenon. So if we can go to the next slide. So what am I talking about? I have a timeline here for COVID-19, and on the x-axis is 2020. On the y-axis is the number of confirmed cases. So in late 2019, early 2020, reports of a number of people in the Wuhan province of China were experiencing flu-like symptoms, and the world didn't pay much attention to it in the beginning. By late January, as the number of cases increased and a rudimentary understanding of the virus evolved, the US took some action, and they issued a ban of non-Americans who had visited China in the last 14 days from coming back to the United States. However, the US didn't do much else, while other countries did much more. It wasn't clear how the virus was transmitted, and there were a lot of disagreements on the best possible way to prevent its spread in the very beginning, such as wearing masks, social distancing, when we should do these things. On March 20th, the state of Maine shut down K-12 schools to limit the spread of the virus. On April 3rd, the Center for Disease Control recommended that people wear masks to limit the spread of the virus once the virus was determined to be spread through aerosol droplets. On June 15th, after we have made some ways of addressing this, on June 15th, after several months of economic hardship, and I'd note no decrease in the number of COVID cases, our governor here in Maine allowed restaurants to open. And then in late August, early September, still with no significant decreases in cases, UNE and a number of other colleges opened back up for classes with appropriate social distancing measures. So there was some understanding of how the science worked, and then there are other people making decisions based on that. Can we go to the next slide? So what I have here is a temperature anomaly from the 1950s of the global world temperature. And what I want to show is there's a lot of similarities between what we just saw and what we're seeing now. So in 1896, so a long time ago, Svante Arrhenius first postulated that increases in carbon dioxide would lead to increases in atmospheric temperatures. However, he wasn't able to adequately demonstrate that, and a number of scientists disagreed with him and his theories weren't widely adopted. Well, over the next 50 years, scientific consensus slowly formed around his theories, and in 1958, Charles Keeling began measuring carbon dioxide at Mauna Loa Observatory in Hawaii. And his work showed that carbon dioxide is increasing over time throughout the atmosphere in rather lockstep with temperature. In 1990, the first report from the Intergovernmental Panel on Climate Change stated that the observed increase in temperature is likely due to increased greenhouse gases in the atmosphere. And then every few years after that, the IPCC came out with other reports, and they became more and more specific. Culminated in the latest report said, it is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century, which is about as conclusive as scientists will ever go on record to say. So in 2015, or at least 60 years after scientists first recognized the mechanisms responsible for climate change, the Paris Climate Agreement was signed that offered up various pledges from different countries to limit their greenhouse gases and keep the world from warming by more than 2 degrees Celsius above pre-industrial levels. I will note that a couple years later, the US pulled out of the climate agreement, citing concerns for our economy. And many climate scientists, in fact, I would say most climate scientists, would say that the pledges by these different countries, even that the United States said that they were too onerous, are still not enough to ward off the catastrophic changes to the planet. So can we go to the next slide? So in addition to COVID-19 and climate change, both phenomena have been addressed and affect areas very, very differently. So you can think of this as different replicates in terms of an experiment. South Korea, China, Hong Kong, and large parts of Europe shut down their economies abruptly and almost completely. This resulted in immediate economic hardship to these countries, but allowed these countries to emerge from the worst parts of the pandemic quicker than countries like US and Brazil and Russia. While there's still the threat of spreading through irresponsible individuals, these countries are on the road to recovery. And they're actually addressing this in different ways by not allowing individuals from those countries like Brazil and the United States and Russia from coming into their country. Can we go to the 6th slide? So this is temperature anomaly all over the world. And what you can see is that the polar regions and different parts of the world are heating at very, very different rates. Red means that it's heating much, much warmer, yellows and whites, much less. So climate change has been addressed by different countries at different levels. However, the effects of climate change are not localized to those who release carbon dioxide and other greenhouse gases in the air. So what happens in the US affects the US. So kind of to sum this up, both phenomena in their early stages were subject to vigorous scientific debate. However, scientific consensus formed and are now relatively well understood. However, addressing both phenomena will require significant immediate economic hardship, but will result in long-term benefits. Whether we're able to make these short-term sacrifices for long-term prosperity is still open to question. So a way to relate this exactly to the students in there, you can relate these two phenomena to your studies. So COVID-19 is like a homework assignment. It's rather short, but still impactful. Climate change is the semester-long project that's going to take a lot longer for us to address. So thanks, and I'll turn it over to Dr. Barry Costa-Pierce now.
Gracias por todos. Thank you, Charles, for everything. I want to start with the big picture environmental climate sciences to emphasize some of the aspects that Charles has talked about. So we as scientists believe we're now in a new geological epoch in planetary history called the Anthropocene, because we haven't seen these conditions in at least 500,000 years. You know, for those of you who know what epochs are, remember Jurassic Park, the Pleistocene, dinosaurs, and all that. Usually an epoch starts in about 3 million years apart. Well, we're in an epoch right now of only 11,000 years old. And as scientists, we think now it's the human-controlled sort of planet of humans that we're dealing with. Next slide. So as Charles mentioned, and you probably know, the ocean is the recipient for most of this warming that's going on right now. Less than 6% of all of the warming is going to the land. So oceans are warming, they're heating, they're expanding. Next slide. So Charles mentioned that that the Gulf of Maine is warming faster than 99% of all of the world's oceans. Well, what's that 1%? The 1% that's warming more rapidly is the Arctic Ocean. And the Arctic Ocean is so different from all other oceans. There is no land underneath there, like the Antarctica. It's an inverse ocean. By that I mean is that the warm waters are not at the surface. The warm waters are at the bottom and the cold waters are at the top because all of those massive rivers from Siberia and Canada pour in cold waters there. So as oceanographers, one of the things that we talk about is in this inverse ocean, all of that warm water is coming from the south. Next slide. So the most dramatic thing has just happened. There's a number of scientists in this vessel, many of which are our colleagues, who have locked themselves frozen in the Arctic Ocean for a year in this German icebreaker. Next slide. What they can confirm, and this is what the Arctic looks like in the summer now, what they can confirm is that the worst case scenario is upon us, that the Arctic will be ice-free by 2035. That's even 15 years. It seems like every new science study is saying, prepare yourself. Next slide. Okay, so what does this mean initially? This is Route 95 coming up from some southern parts of the mid-Atlantic through Narragansett Bay in Rhode Island. All the blue shows that 95 is completely underwater, and on the left side is all of the oil infrastructure for southern New England, which many of the people in this region depend upon. So what is going on, first of all, is the melting of the Arctic is leading to the not only the thermal expansion of water, but pretty much we're getting not only high tide flooding right now in places of like Miami, where, you know, no matter whether they think about climate change, believe it or not, they're having to deal with it as local officials. But now the Great Flood is coming because of the melting of the Arctic, which will basically flood all of coastal infrastructure by 2030, 2035. Next slide. Okay, climate isn't weather, and weather is not climate. You've heard that, right? But climate is changing the weather, and I want you to understand how dramatic the changes that we're seeing right now have occurred in the last couple of years and are going to occur even more so over the next few more decades. Okay, so as meteorologists, as oceanographers, we know that the ocean is tied intensely to the atmosphere. And we hear about, and the winds move from west to east, they call the westerlies, storms move from west to east, and we hear all the time, oh, you know, the winds are decreasing, the winds are increasing. Well, when 50 years ago, some of the scientists predicted that the first major signal that we were going to all have to deal with is this massive variability. Next slide. Okay, so I'm going to give you a sort of shocking couple of examples of the massive variability that is being caused right now because of a nearly ice-free Arctic. No nation on this planet will be separate from what is going to go on in the Arctic right now because of this ice-free. Okay, so this is one of the things that's happening right now to the jet stream, which I showed you earlier, which moves weather systems from the great generator of all weather, the Pacific Ocean, into the Atlantic Ocean. What we're seeing is these massive dips in the jet stream. Some of them get stuck, some of them move fast. Next slide. So two events have happened. This one happened last year, and I'll talk about one that happened just this year. Last year, because of that big dip, we saw record all-time highs of over 100 degrees in Alaska. You heard about over 100 degrees in Siberia. Next slide. On the other side of that dip, in September of last year, was a historic snowstorm in the Rocky Mountains. Now, it's not unusual to have that there, but this was historic. It never had occurred. Temperatures were lower than had ever been seen before. Next slide. And then this year, you heard about this. Now, let's look at where we are. Now, latitude is like our position from north to south from the equator, 0, to 90 degrees north to the Arctic. So Denver is about 40 degrees north latitude, Maine is 43, okay? And what we're seeing in these conditions here is on the other side, Denver went from 100 degrees Fahrenheit, it dropped, as you can see, in less than 24 hours, 58 to 55 degrees, okay? Temperature change. It snowed the next day after 100 degrees Fahrenheit. Next slide. Okay, so we talked about those dips, right? We talked about, so on one side, record warmth, Alaska, warming to a level of Hawaii. On the other side, like massive winter occurring before it is supposed to occur. But this is Mexico, okay? This is Guadalajara, Mexico. This is 21 degrees north. This is in the tropics, okay? Next slide. So July 1st, Guadalajara, Mexico, in the tropics, had been enjoying a sweaty summer until residents woke up the next day to 3 feet of snow and ice. Next slide. And this is the 3 images. You can't even believe your eyes in the tropics to see this. This level of variability is the new normal that we're experiencing. Next slide. So this is based upon what Charles just mentioned. It shows a different way of the pandemic that spread across the globe. So back in the day, we used to sort of say, in my generation, when I was at your age, the students at UNE, we used to say sort of think globally and act locally. And now nationalization is not serving us well. The pandemic spread globally, and we need scientists in China, Europe, and the United States, and all of the other countries to be involved, not only with how the pandemic spread, but how the pandemic is going to be spread with climate change. So now the new rubric is not only to think globally, but to act globally and act locally. So my message to you is that internationalization of science, being fluent in languages and cultures, is going to be one of the keys for the future of climate change and understanding pandemics that are going to come. Thank you.
Thank you very much, Dr. Costa-Pearson, Dr. Tilburg, for giving us so much to think about. So I'm going to wrap up the presentations here. I'm going to approach this issue from a slightly different lens. So with apologies to the great Tina Turner, who wanted to know what love has to do with it, I'm going to consider what law has to do with it, because I'm not sure, and I know we have a lot of med students and science students that I've seen come in. I'm not sure we always connect the dots between the law and science with either a global health crisis or climate change. Next. So I approach issues thinking about this Venn diagram. This is my brain. I think about how the laws intersect with science and influence policies and vice versa. Now, this doesn't always happen. I think it probably happens more often than we think about it. For example, we apply science in all kinds of ways in the marine environment. How many fish to take out of the ocean? That can impact policies related to fishermen, fishing communities, and even seafood consumers. Similarly, the science of public health is applied to the legal framework we live under in many ways. And again, off of Dr. Costa Pierce's piece, globally to locally. So we have different policies about requiring vaccinations in schools, requiring concussion protocols in sports, travel and quarantine restrictions during the pandemic. Next. So I'd like to consider today the role of political leadership and institutions in responding to the two situations confronting us today. Neither the pandemic nor climate change respect geographic boundaries, political affiliations, gender, or age. In fact, both the pandemic and climate change reveal weaknesses in our governance and management systems, particularly in response to our most vulnerable people and communities. So does political leadership at the local, state, national, and international level matter in a global crisis? Next. Well, we've certainly seen very different responses to COVID-19. Some countries were very restrictive in lockdown measures, some were very lenient. In the United States, individual states, towns, universities, and school districts have all responded very differently to the same virus. And we see wide variations in infection rates and mortality. Would we be at a different place now in September after nearly a year of grappling with this virus if we'd had a more unified response across states, nations, institutions? Next. So climate change clearly represents, I hope you have gotten that from our previous two presentations, a global situation that's triggering a variety of responses at many levels. So Dr. Tilburg mentioned the IPCC. They've been producing reports, including reports aimed directly at policymakers. The Paris Climate Accord, as was mentioned, and even right here in our home state of Maine, we had a Maine Climate Council that worked last year through the pandemic with umpteen Zoom meetings and produced a lot of recommendations that the legislature is now considering. Next. Different countries are responding to the same climate change challenge in different ways as well. Some are really leading the charge. Germany, for example, is a country that's come up with some very specific targets for reducing greenhouse gas emissions. The US, no coherent policy at all. The Great Britain and the UK are leading the world in establishing offshore wind farms. The United States, we have a modest operation located off the coast of Rhode Island. Next. And as was mentioned, we certainly see impacts of changes in political leadership. Now, this can be in spite of no actual change to the law. So over the past few years, the Trump administration has rolled back many advances that the Obama administration made in addressing climate change, including announcing withdrawal from the Paris Climate Accord, gutting the Clean Power Plan. This is despite the fact that in 2007, the US Supreme Court ruled that, yes, EPA, you actually should regulate greenhouse gases under the Clean Air Act. It's still good law, but political leadership can certainly erode application of good law. Next. However, we see more action at the state level frequently in responding to almost any issue, and the same is true for climate change. State governments are smaller, they're more nimble, they have a more unified set of purposes among their residents. So some states like California are really leading the charge. They're not waiting around for the federal government. In fact, they've been in blatant opposition to many of the Trump administration's policies. Cities like New York, Boston, and Miami, they're not waiting around for the federal government. They're seeing the impacts of climate change now, and they are working hard at coming up with adaptation and mitigation measures. Some states, however, are going the other direction. So for example, in 2012, the North Carolina legislature passed a law prohibiting any mention of sea level rise and the science related to it in their planning for coasts. So if you don't think that science and law have something to do with each other, there's a great example for you. Next. So we're seeing uneven issues to global issues that just don't respect differences. This is what I always tell my students is a leading question. Does this make a difference in our response? Well, maybe if for no other reason than efficient use of resources. Clearly, we know the pandemic has had dramatic impacts on our economy and our resources across the board. In healthcare, in education, people are stretched to the limit. We're witnessing unprecedented wildfires as we speak on the West Coast and the most active hurricane season in history. This is stretching emergency response resources as never before and affecting thousands of people. Next. And Dr. Costa-Pierce set this up for me perfectly. The reason this matters is because climate change, like the pandemic, is global and local. We're seeing the impacts in our oceans, our coastal communities, our individual lives. I suggest that we can learn from the pandemic the very real cost of not taking a uniform approach to a common threat. Next. Our young people are not waiting around either. As they did during the civil rights movement, the Vietnam War, they are demanding action in response to climate change for their future. So what can be done? This is a big, daunting problem. There is something everyone can do for future generations in the very near future. Next. Democracy is not a spectator sport. As of September 17th, we have 47 days left before Election Day. We've seen what chaotic leadership means in response to both a global pandemic and climate change. This election is essential to determining the leadership we will have to confront the challenges of the future. Thank you. That's the end of my formal remarks. So we're going to turn now to see if we have any questions from the audience. Caitlin and Colin, you've been monitoring what's been going on. Caitlin, I'll check in with you first.
Sure. So just some general questions. So one might be, what action can individuals, groups, or populations take to slow the progress of climate change?
Well, I can,
Gary?
yeah, one thing that has really caught my attention is that there's a movement, a global movement afloat called the Half Earth movement. We have a chance now. If we can save half of the Earth, we have a chance to ward off the very, very worst of climate change that I've mentioned. What this means is if you take all of the natural areas that are remaining, all of the national parks, and you add indigenous lands to it, we still have half of the Earth that is preserved. And that half Earth has the essential ecosystem goods and services and climate control mechanisms. So policymakers who are trying to denigrate national parks, trying to degrade natural ecosystem services. That's what we can do. We can watch what's happening to the last remaining gray areas on the Earth to make sure they get preserved. And we've got a chance.
Wonderful. Oh, sorry.
I would actually like to talk about something that is just completely, what you can do today. We're going to talk about a lot of, we're going to talk about different things that you can do that are like grand strategies. However, what you can do today, or what you can do in 47 days, as Professor Faraday said, is you can vote for candidates that support the environment. And something else that you can do is that you can make wise purchases. You can make it so that companies see that it makes sense to create sustainable goods. These are things that you can do right now. Your recycling, your individual actions where you're decreasing your carbon footprint, while it's admirable, that's not going to make that large of a difference if that is all that you do. We need to convince companies and countries that they need to make changes. Like one of the things that I always like to point out was that during the COVID-19 pandemic, where all of a sudden we stopped driving and we stayed at home and our greenhouse gas emissions went down, 2020 is still going to be the warmest year on record because individual actions aren't enough. Countries and companies have to make changes. The way that you can do that is you can vote and you can make informed purchases and get everyone else you know to do the same two things.
Thank you, Charles and Barry. I'm just going to let everybody know, I wish we had more time to take everybody's questions. We've got about 7 minutes left. So Caitlin, I know you're doing your best to kind of curate and collate questions. So any particular other issues we can address?
Yes, so Rachel would like to know if anyone can speak about how climate change and COVID-19 disproportionately affects different groups, like such as the Global South, if anyone could speak on that.
I'll take first stab at that one. I think both of these situations just show glaringly the frail fabric of government institutions. So the most vulnerable among us, whether it's due to racial inequity, economic inequity, lack of access to healthy food, clean air, medical care, they're the ones that really are suffering, both at the hands of the virus and by the impacts of climate change. So for me, again, thinking about sort of institutional leadership and political leadership, these are unacceptable situations. They're unacceptable in my mind. And the institutions and the laws that guide how we as a society take care of the most vulnerable among us need to be changed.
Susan, would you like me to also address that same?
Sure.
I mean, I would say one thing about climate change on how it affects different groups is that in the West, where we are creating most of the greenhouse gases, we're going to see less effect in the low-lying areas of Southeastern and Mid-Asia. Like places like Bangladesh, places like Thailand, places like Southern China, Indonesia, places like that are going to see catastrophic sea level rise, and they do not have the infrastructure to actually deal with this. And so one of the great cruelties of climate change is that those that have had the least, have caused the least amount of damage are going to be affected the most. And so I think, this is a global problem. This is also a moral problem, and that we here in the West have the resources that we're going to be inconvenienced by climate change. Those in the Mideast and Southeast Asia and South America, those that do not have the resources that we have, are going to be devastated by it. And it is patently unfair that the people that caused it are not the same that are going to be affected by it.
So one comment about that is that, and I feel very strongly about the people who in Europe and North America who are trying to build walls. We're on the beginning stages of a massive global mobility. And Charles just mentioned, remember, most people live in Africa and in Asia, and these are our brothers and sisters, and they are going to need the global North's assistance as we get a flood of global climate refugees. We are going to have to build bridges, not build walls to these people who are going to be in a desperate state, and they already are, if you're looking what's going on in the Mediterranean and certainly in this southern border.
Thanks, all of you. We have about 3-4 minutes left. Caitlin, other things we can respond to?
Yes, so just a few questions regarding to UNE's involvement investing possibly in using oil for heating, or if there's a way that we could have a petition for the school to change to cleaner energy, or other ways that UNE is currently reducing their carbon footprint. There's some questions regarding that.
So that's a great teaser for our November event, which is going to be all about issues of sustainability. I'll say one brief comment. Two things. So the Northeast is incredibly dependent on heating oil. We're more dependent on heating oil than any other region. So that's not just a UNE problem. It's a problem in my house too. So I don't know UNE's investment portfolio. I do know one really awesome thing here at the Marine Science Center is we have solar panels. And when you walk in, you can actually see how much energy we're getting from those panels. So there's certainly opportunities for improvement for sure.
I would also point out one other, particular tangible thing that the University of New England is doing, and this happened 2 or 3 years ago, is that the College of Arts and Sciences decided that all airline flights, we were going to offset the carbon generated by all airline flights. So everybody who flies in the College of Arts and Sciences, we then work with Alethea to determine what the carbon footprint of that was, and then we purchase carbon offsets. Now, I would like to mention that the solar panels on the Marine Science Center, these are baby steps. We are not even close to actually meeting our goal of being carbon neutral. And so we have a long way to go, but we are showing that it is possible to decrease our carbon footprint.
Great, thank you. I think we have time for maybe one more, and then we're going to have to wrap things up.
I think from what I'm seeing, that was pretty much the majority of the questions. So thank you to everyone who did send in a question. We appreciate it. Yeah.
Thank you very much. Yes. So these are stressful times. I don't know a single individual I don't interact with, whether it's my friends, my family, my colleagues at work, every one of my students. We are all like this. And sometimes I tease my students that my classes are the feel-good classes because we talk about climate change and what a problem it is. So I want to end with this. We started talking a little bit about solutions, baby steps, but there's big steps too. But I want to give each of our panelists an opportunity to reflect for a minute or two on what gives you hope. So Charles, do you want to start off with that?
Sure. I'll talk about two things. One of the things that I have looked at is that I've looked at the amount of carbon produced per capita of Americans. And the amount of carbon that is produced per capita of Americans from the year that I was born, 1970, until this year has decreased dramatically. If the world's most wasteful country can decrease carbon dioxide emissions per capita, I see that this is a solvable problem. And I would say more immediately, the thing that gives me the most hope was actually something that I participated in. I think it was last week, but during COVID, I never remember when anything was. Time seems to have lost all meaning here. Was the Black Lives Matter March here on campus. There were professors there, the president of UNE was there, and we took a complete back seat to students who ran that entire thing, who organized that, who supervised it, who made certain that everything worked. This new generation, this generation that is, most of the people that are watching this, is one of the most involved, committed, generations, passionate generations that I have ever seen. And this is the generation that is going to solve these problems because they are doing things that the previous generations refused or couldn't or what you want to use. did not do, and you guys are going to solve them. Now that doesn't mean that we're going to stop, but I see great hope in this next generation of Americans and of the world's inhabitants.
Barry, thoughts?
Beautiful, Charles. So Gandhi said, be the change you want to see in the world, right? So you got enough science. Science is a slam dunk, we don't really need any more science. Science is great, but my message to you as little as 5 years ago would be along the lines of adaptation or resilience as ways forwards. My message to you is very similar to what Charles said. It's action. It's time. Radical transformation is really an internationalization, and having that implemented locally is really the only ways forward. The old science notions, and they're only like old 5 years of tipping points, avoiding them, and even the Paris Accords is, ancient history, right? They no longer apply because we didn't take action. You didn't take action on the science, didn't take action on the Paris Accords, okay? So Charles is absolutely right. The advent of the Greta Thunbergs of the world, right? And our admiration for you. I have to admit to you as a young person, you called us hippies. Take the negative side away from that, about some of that. But there was a dream that we could actually have a sustainable world. And, there was something called the Earth Action Plan in 1972 and Earth Day. And we're right with you. What we didn't take enough action. And now what gives us great hope is that you are. And we are right there with you.
Thanks. Thanks, Barry. Thanks, Charles. So my reflection on this question, broken record, it's youth that give me great hope. I'm seeing the innovation. I'm seeing the passion that this generation is bringing. I implore you, bring your action and your passion to participating in our democracy. It's really important. The second thing that gives me hope, there's a bumper sticker that I saw years ago and I didn't buy, and I'm kicking myself because I love it. It's Mother Nature Bats Last. Because it's about nature, it's about sports, I love them both. When we give Mother Nature a break, she's pretty remarkable at recovering. Natural systems, species, when we get out of the way, a lot of natural systems sort themselves out just fine. They don't need us, right? So things as you took from this all these presentations, we're getting to a place where that's not going to be possible. But I am hopeful that based on the passion of the young people of the world today, that we're going to give Mother Nature a chance to bat last. So that's all I have for you today. We have a couple of housekeeping events. There's a survey up in the chat, and I'm going to turn it over to Alethea with some closing remarks.
Thank you, Susan. I just want to thank all of our panelists one more time, Susan, Charles, and Barry, for sharing your expertise, your passion, and your time with us. And thank you to Colin Bader and Caitlin Irish for helping us with the audience participation from Facebook Live and the Zoom chat. We are at the end of our time, but a few closing housekeeping items like Susan mentioned. I'm going to do a quick little share screen with you again. So this event addresses the interprofessional competencies of roles and responsibilities, values and ethics, and teams and teamwork. And it can be applied toward students' interprofessional honors distinction badge. Please take a moment to complete the attendance survey. You can connect to it via the QR code on the screen or copy it and paste it from the chat section of Zoom. We want to thank our colleagues in CC, Chris Hall, Lisa Boucher-Hartman, and Michelle Cody, and our technology masters behind the scenes, Dave Dadiego and Lee Cody, for their partnership and assistance throughout this event series. Couldn't have done it without all of you. We invite you to join us again next month on Thursday, October 15th at noon for Pandemic Reflections, Protecting Public Health from COVID to Climate Change. And then the November discussion will address issues of sustainability surrounding COVID and climate change. We hope you all will join us for these discussions as well. Again, remember to take a few moments to complete the brief attendance survey. And thank you again so much for joining us. Be safe, be well, and do good work. Have a fantastic day, everyone.